Hello again, fourth graders. This is Mr. A, and we are reviewing fractions, and we're using benchmarks half and one. You know, those benchmarks are so helpful. They're so helpful, and I want you to use them, fourth graders. I want you, whenever you have a fraction, if you want to decide if one fraction is bigger than the other, go and use the benchmark half and a whole, because a benchmark means it's something that is easy to compare to. A benchmark is a sign or a mark that is so easy to help you figure out the quantity of something. So, for example, an easy benchmark is a full set, right? When you have something full, that's easy to compare quantities with, okay? Um, Half is also an easy way to compare quantities, okay? Half of something, the full of something, those are easy ways to figure out whether one quantity is less than or greater than the other, okay? Remember, whole means full, means one complete set, right? So the one here, it means full, it means whole, complete, okay? And half means half of it, half of a whole, half of a full, half of a complete set, okay? So the question is, 6/8, is that more or less than a whole, than half? Okay, so let's draw a hole, okay? And remember, you have to keep them the same width. You have to have the same quantity. You can't have uh, a hole this size and then a hole this size. No, this is not gonna work because we're not talking about the same whole. Okay, so when we're comparing fractions, they have to be the same whole. Okay, so here's half. Now we're looking at 6/8. Is that more or less than a whole? Well, if I take uh, 6/8, it tells me that it was a whole that was first partitioned into eighth. Now 8 is an even number. 8 is a number that you can get from 2. 2 one time is 2, 2 two times is 4, 2 3 times is 6, 2 4 times is 8, right? So 2 and 8 are related. So I'm going to divide this second whole, this one that I'm going to color in yellow, okay? I'm gonna partition it into half, because half is 2, okay? And then I each half needs how many? It needs 4. If I partition each half into fourths, what's going to happen is that I'm going to have a cleaner partition. See how my partitions are almost identical? And that's what we want, because when we use fractions, we want the pieces to be equal, right? So now this is 8/8. This is 8/8. So the denominator 8 tells me that there is a whole that was partitioned into eighths. Okay? Now 8/8, that's a full whole. That's 1. Okay? But we are comparing 6 pieces of eighths, 6 pieces of eighths to half. So here is half, and I want to compare 6 pieces of 8s to it. So I'm gonna cross out 2. 1 is out, 2 is out, so that gives me 1/8, 2/8, 3/8, 4/8 is the equivalent. 4/8 is the equivalent. It's the same as half because 4 is half of 8, right? So 5/8 is more than half. 6/8 is definitely more than a half, right? So 6/8 is more than a half, okay? So using the benchmark half and full, whole are very helpful when you need to compare two quantities, two fractions. Okay, you have to just draw a whole for one fraction and a whole for the second one and compare whether one of them is more than a half or if one of them is closer to a whole. Okay, so I hope this video is a good refresher. I want to see on your homework a model of a whole and one for one fraction and the another one for the second fraction, and I want to see the partitioning, I want to see your reasoning, I want to see evidence that you are learning because I want you to succeed. Okay, I want you to grow and reach your potential. Okay, all right, so let's say we have, you can pause the video if you get the message, but if you want a second one, let's do a second one. So let's say we have I'm gonna pick a random number here. Let's say 7, and we have uh 5/7. Okay, 5/7. Is that more or less than a whole, a full? Okay, so I'm gonna draw a rectangle for my whole, okay? And then I'm gonna go draw a second rectangle below it just so we can keep the same width, right? So we are being accurate when we're comparing the quantities, okay? So this is a whole. I'm gonna color it in pink, in orange. This is my whole. It is a full, complete set. It's not missing anything. Okay. Now my second one is 5/7. It is a whole that was broken into sevens. So here is half. I can get with 2, 4, 6. So I'm gonna push it just a little bit. Like I'm gonna push my half like just a little bit here. And here's my because 7 is an odd number, so I'm gonna divide these into thirds. 1, 2, 3. 1, 2, 3, and then here is my sevens. Okay, so I pushed the pieces a little bit, so I can have 1, 2, 3, 4, 5, 6, sevens. So I have now a whole that is partitioned into sevens. How many of those sevens are available? I have 5 pieces are available. I need 7 pieces to get a full set, but I have only 5 sevens. So I'm missing 2 pieces. So that is not a full set. That is less than a whole, right? That is less than a whole. So which is more? The one. 5/7 is less than a whole, full, complete set. Okay? So if you still have questions, please talk to me in class. Let me know. and we will come up with a plan.